In section 1-2, we're going to talk about the properties of real numbers. The first property we're going to talk about is the additive identity property. This property states if I have a number and add 0 to it, I'm going to end up with that first number. Okay, now 0 has a special name in this case, and that is the additive identity. In addition problems, 0 is always the additive identity, because when I add 0 to something, I always get what I started with. So notice 0 in both of these problems is the additive identity, because if I take the first number, add 0 to it, I'm going to get that first number I started with. The next property I'm going to talk about is the multiplicative identity property. This is very similar to the previous property, but in this case we're multiplying. Notice if I take a number times 1, I will get that original number I started with. Okay, over here I have an original number, I multiply it times 1, and I get that number I started with. Now in this case, these ones are called the multiplicative identity. The next property is the additive inverse property. This states if I have a number and add its opposite, my answer will always be 0. So over here, notice I have a number, I add its opposite, and I get 0. So notice these two right here are opposite of what you started with. Okay? But we're not going to call it the opposite. These numbers right here are going to be the additive inverses. Okay, and notice that the word opposite and additive inverse are synonyms, or in other words, they mean the same thing. The next property we're going to talk about is the multiplicative inverse property. This property states that if I multiply a number times its reciprocal, I will get 1. Once again, over here with algebra, I have a number times its reciprocal, and we end up with 1. So notice these two numbers are reciprocals of the first number in the problems that we have. But we're not going to worry about calling them reciprocals. These are the multiplicative inverses of these two problems. Now we are going to use what we just talked about, all those properties, to do example 1 here. Example 1 says find the additive and multiplicative inverse of each number. Okay, so remember, the additive inverse is the same thing as the opposite. Okay, and also remember that the multiplicative inverse is the same thing as the reciprocal. Okay, so in letter A here, we need the additive inverse, which is going to be the opposite, so I'm just going to abbreviate here that the additive inverse is the opposite of a negative 9, which is a positive 9. Okay, and the multiplicative inverse, and once again I'm going to abbreviate here, the multiplicative inverse is the reciprocal. So the reciprocal of a negative 9 is going to be negative 1/9. In letter B, we want to do the same thing. So once again, in letter B here, I know that the additive inverse is just going to be the opposite. So the opposite of a positive 4/5 is a negative 4/5. And then the multiplicative inverse is just the reciprocal. So I'm going to abbreviate that there. The reciprocal, all I need to do is flip that fraction around, flip the numerator and denominator, and I get 5/4. The next property we're going to talk about is the closure property. The closure property states if I add together two real numbers, 2 and 3 are both real numbers. So when I add together two real numbers, my result will be a real number. Okay, also here, same thing goes for multiplication. If I multiply two real numbers together, my answer is going to have to be a real number. The next property we're going to talk about is the commutative property. The commutative property states if I'm adding two numbers together and I switch the order around, it's not going to change my answer. So right here I'm adding two numbers together, 7 plus 11 is 18, and notice if I change the order of the two numbers I'm adding together, the answer does not change. Okay, the commutative property also goes for multiplication. I can change the order around of when I multiply and it doesn't change my result. So notice here 7 times 11 is 77, and over here I switched the 7 and 11 around and still multiplied them, and I ended up with the same result. The next property we're going to talk about is the associative property. The associative property mainly deals with grouping numbers or the numbers in parentheses. So notice our addition problem here. The 5 plus 3 is grouped, so that means we have to do that first. So 5 plus 3 is 8 plus 7. Okay, 8 plus 7 is 15. Now notice the associative property tells us if I change the two numbers I group in the addition problem, I should end up with the same result. So notice here in the second part of this problem they grouped the 3 and the 7, so we have to do that first. 3 plus 7 is 10. I bring that 5 plus down. 5 plus 10 is 15. So notice even though we grouped two different numbers, we still ended up with the same result at the end. This property also goes for multiplication. So notice right here, the 5 times 3 is grouped together, so I have to do that first. Okay, and I'm going to keep it in parentheses, and I have to bring that 7 down. Okay, now I need to do 15 times 7, and I get 105. Okay, now notice over here, two new numbers are grouped. Now the 3 and the 7 are grouped together. Okay, 3 times 7 is 21. And I'm going to keep that 5 out front. 5 times 21 is 105. So notice, even though I grouped two different numbers, I end up with the same result. So the associative property tells us when adding or subtracting, if I group two different numbers, I should still get the same answer. The next property is the distributive property. Okay, and the distributive property tells us that we can multiply this number out front by both of those numbers inside and then add. So what the distributive property tells us is we can do this equals 5 times 2. I draw this arrow to say I'm multiplying, and this middle sign's a plus, so I'm going to have plus, and then I have 5 times 8. Okay. Alright, the distributive property works also if I have the two numbers grouped in parentheses out front. So I'm going to do 2 times 5 plus, now I'm going to distribute the second one, plus 8 times 5. Now if I multiplied this side out and did this side, I'd get the same answer. If I use the order of operations over here, I would get the same answers if I use the order of operations over here. Now, example 2 says identify the property demonstrated by each equation. Okay, so I'm going to look here in what we talked about now. What I notice is that we did 3 square root of 3 times 2 plus 5 times 2, and I remember when we do that this is the distributive property. Okay, so I'm going to write that this is the distributive property. Okay, and the next one, once again, we're identifying properties now. I notice that on the left side of the equation here, this 3 and 6 are grouped together. But now over here, I notice that both of these 6's are grouped together. Anytime we're changing the grouping of numbers, it's always the associative property. So this is actually going to end up being the associative property. Now we got to say of addition or multiplication because there's both choices and we're adding here, so I'm going to say of addition. Once again, we're trying to identify the property in these examples. So in example C, notice I really have 9 times the square root of 2. And over here on the right side, I have the square root of 2 times 9. So notice I changed the order I'm multiplying. So I changed the order I'm multiplying. So anytime I change the order, okay, it's going to be the commutative property. And once again, anytime we have the commutative or associative property, we're going to say of addition or of multiplication. So in this case, we're multiplying, so I have the commutative property of multiplication. Finally, our last example here, it says example 2, identify the property demonstrated by each equation. So once again, I look at the left side. Look at the left side of the equation and the right side of the equation. Now over here I notice 12 times pi is grouped together. But now over here I notice that the 9 times 12 is grouped together. So notice the order of the numbers is the same, 9, 12, pi, 9, 12, pi. But notice the same two numbers are not grouped together. So when I'm talking about changing the grouping of numbers, I'm talking about the associative property. And now whenever we have the associative or commutative property, we're going to say of addition or multiplication. So I have the associative property of, and we're multiplying here, so I have multiplication.